Alright, good morning ladies and gentlemen. Today we have a short lesson about the probability of rolling two six-sided dice and adding their combinations together, or adding them together to make a combination. Now I've done a lot of the hard work for us by setting up these tables. See the results you would get if you roll the first dice down here, and the results you would get if you roll the second die this way. And adding them all up gives you all the numbers between all these numbers. Now, first thing you should notice is that the probability of getting a 1 or a 13 is equal to 0, because, ladies and gentlemen, there's no way you can get a combination of any number greater than 12 or less than 2 when rolling two six-sided dice and adding their combinations together. Now, if we quickly put the probabilities up here, probably 2, 3, 4, probability of 5. Maybe I should have done this part ahead of time also. Probability of 6, probability of 7, probability of 8, because each one of these have individual probabilities. Probability of 10, probability of 11, and a probability of 12. Since these all are possible events within our space of dice, or space of rolling the dice, they each have their own individual probabilities. And it could be anything of the form E over T. Now you might consider, what is your total number of combinations here? Well, how many sides do we have? We have 6 possible ones that we have here, and 6 possible ones that we have here. And 6 times 6 would give us 36. Oh. Now, if only is out, the probability of getting a 3 is 2 out of 36. Probability of getting a 4 is 3 out of 36. Probability of getting a 5 is a 4 out of 36. And ladies and gentlemen, at this point, you might be seeing a pattern, because probability of getting a 6 is 5 out of 36. Probability of getting a 7 is 6 out of 36. But at this point, it starts going the other direction. Probability of getting an 8 is a 5 out of 36, a 4 out of 36, a 3 out of 36, a 2 out of 36, and a 1 out of 36 for probability of rolling a 12. It goes in a pattern. All those patterns are what is in here. How many 7s do we have? 1, 2, 3, 4, 5, 6. And that's the one that has the greatest distance across. You can only have the highest probability is rolling a 7, and we can see that because we have 1, 2, 3, 4, 5, 6 7s here, because it has the greatest combinations of 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. Everything else just kind of decreases from there to where you only have one way of getting a 12 of 6 and 6, and one way of getting a 2 being 1 and 1. Everything else can just be seen through its diagonals. The 4s are 3 and 1, 2 and 2, 1 and 3, so on and so forth. That's why this is built into a lot of those casino games, where like, hey, try to roll a number before you roll a 7. Well, that's very difficult, or at least it can be difficult, because 7 comes up the most. And if you're having saying, oh hey, put a lot of money on Snake Eyes, being the 1 and 1, doesn't make a lot of sense, because there's a very low probability that you're gonna get Snake Eyes, or there's a very low probability that you're gonna get double 6s. Ladies and gentlemen, any and all probabilities can be written out through mathematics. It's all math, ladies and gentlemen. Well, that's our end of our little 5-minute lesson today. Hope you guys all have yourself a wonderful Friday and a great weekend. Bye.